Dr. Philip Orton. So Philip is a research associate professor of ocean engineering at the Stevens Institute of Technology in Hoboken, New Jersey. He is a physical oceanographer that specializes in coastal physical oceanography, storm surges, flood risk assessment, air-sea interaction, and coastal engineering. He has authored over 60 peer-reviewed papers, contributed to the New York Times Sunday edition, and has served on climate panels for New York, New Jersey, and the IPCC. So I will let him take it over from here and share more about what's happening with his work here in New Jersey.
Thank you, Tina. And nice to see some familiar faces on the line out there. All right, let's go. My collaborators on this are Laura Kerr and Tom Harrington, who's also on the call. Observing and forecasting coastal flooding in New York and New Jersey. I'll also talk about wave measurements that are planned in the future with some of the new MARACOOS related funding. The overall plan is to just give some motivation for improved observation systems for flooding, talk about this existing Stevens Flood Advisory System, a survey that we conducted on its users that really informs the benefits of this work, the benefits of using flood cameras for observation that were funded by MARACOOS, which include evidence of flooding, validation of our flood models and forecasts, quantification of flood area via image segmentation, AI methods, supporting machine learning modeling for flood nowcasting, meaning for the next few hours, aka flash flooding, et cetera, from rain and coastal sources. I'll talk about the plans for a new project funded by MARACOOS for the New Jersey's northern coastal bays from Atlantic City up to the very northern part of the coastal back barrier bays at Bayhead. And lastly, I'll talk about where we are in our research and what conclusions we can draw from this. So as everyone knows, the frequency of high tide flooding is rising. This picture is actually sunny day flooding from a flooding event I went to in Hamilton Beach, New York City, a place where, as of 2020, there were about 50 floods per year, certainly approaching 100 floods per year of that magnitude, or just below that magnitude, where it just starts to creep into the neighborhood. That's actually just exceeding, it's not a minor flood yet at that point. There's about 20 minor floods per year at that location, but there's an intersection into the neighborhood, critical intersection that begins flooding about the same time as this location, which, like I said, happening almost 100 times per year now. And many drivers cause coastal flooding. It could be the river flow, the pluvial forcing, the rainfall, or it can be the tides and storm surge. In the past, we've only observed the water levels in rivers and tide gauges and estuaries and the ocean, and those aren't even really flood observations, they're water level observations. So we have metrics of what water level exceedance leads to flooding, and that's what the last figure was informed by, that flood threshold, or one really that I observed myself by being there. So there's many sources of flooding, and there's also compounding of the different sources. There's also groundwater emergence in some places also. So understanding coastal flooding really will require more data in new places, and that's been a realization, and there's many different scientists working on broadening our perspective on coastal flooding using different sensor approaches, like I'll talk about today. Some background, and I noticed Alan Blumberg's on the line and Tom Harrington. They're part of the past team that developed forecasting at Stevens. It's gone on for 20 years now. The current system is called the Stevens Flood Advisory System. It provides coastal water level forecasts plus an uncertainty range, a 90% confidence interval in a time series format that I'll show in the next slide. And that includes river effects and coastal tidal and storm surge effects, but it doesn't include pluvial sources of flooding, so that's one shortcoming. And it sends emails for flood watches and advisories out to 4 days, same day advisories or warnings, essentially the same day as flooding is expected, but also 4 days in advance as a flood watch to get people's attention. And that's for the whole region, but predominantly New Jersey, New York, where there's the most observations. And it just provides forecasts at the observation stations at the tide gauges. It doesn't provide actual flood forecasts. It provides flood water levels, and then relative to the thresholds that it can trigger warnings that are sent out to people via email. And so we use the National Weather Service thresholds, the forecast water level shown in magenta, the observations are shown as red dots in the past, and that 90% confidence interval shown as the gray shaded area. So, I mean, one thing we know, especially after storms battering our region like Sandy and Irene in the past 15 years and other storms, is that giving one central forecast, also known as the deterministic forecast, is not as useful as giving a range of predictions or a confidence interval, or even letting someone tap into the probability of flooding at their particular location. So this is just shows a confidence interval around the prediction in the system. And we have assessed this system increasingly. Nikitas Georgios was a major developer of the system. He's now with Tetra Tech RPS. Mahmoud Ayad published a paper in 2022 on Isaias, assessing the system and its performance. And then now we have a manuscript submitted to Journal of Geophysical Research with Nikitas and others involved, assessing the system over 2 years of its performance to give a real probabilistic assessment of the spread, the uncertainty estimates, and the central forecast. And another thing we did about a year ago, we conducted a survey of the existing about 1,500 users that receive our emails. We had responses from over 20%, 351 respondees, and a very large response, I didn't expect it, comes from the New Jersey Back Bay regions, and where we actually don't feel we have our most accurate forecasts. And some of the users said, your forecasts aren't as accurate as we'd like, but they're the only game in town because there is not forecasting from NOAA on the backside of the barrier islands in these narrow, these back bays that are fronted by very narrow inlets. They're not resolved well by the NOAA models at present. And so we're the only forecast they have, and they find it useful, and they learn how to use, they can learn its biases and its, where it's useful and where it's not. And a lot of users are on Long Beach Island and locations like that. What we did learn that was really positive was what people use these forecasts for. The government users, and people could designate whether or not they're government, company user, or household user, essentially. The common response activities from government were moving cars to higher vehicles to higher elevation, closing roads, emergency management activities, closing tide gates and storm surge barriers. We know at Stamford, Connecticut, and on the bay shore of Raritan Bay, New Jersey, there's barriers where they do consult our forecasts, and it helps them decide when to close their barriers. And a majority of the respondents were household users, who about half of which said they're flooded several times per year or more. Common response activities, again, moving cars, adjusting their schedule, applying flood protections to the home. And one thing that we've concluded from this is that this is enabling people to live with the water. There's a lot of people eager to use this kind of information because they're being flooded so frequently, and it helps them to live in the community they want to remain in for longer, dealing with up to 1 foot of water and chronic flooding. So how do we make these flood forecasts more usable by society to motivate our observation improvements that we're doing? You make them apply to the locations where people are. Instead of a gauge somewhere on a waterway nearby, you give them a map instead of a water level number with a vertical datum associated with it that only experts tend to understand. And you make them more accurate, and also without using vague terminology like minor flood or moderate flood. You show them a map. You make them more accurate, and you include all water sources, including rainfall, because water, for the most part, water's water. Salt water can cause more damage, but to a resident, whether or not they get flooded in their house is all that matters. And these are the goals of our work with the MARACOOS funding. So we've deployed cameras. They're off-the-shelf cameras from Railink in the case I'm using. These are 2 out of the 3 cases we've deployed so far. This is from March 2025, a day with heavy rain. On the left is Hoboken Terminal location, now actually under construction for raising that parking lot by 3 feet. So I'm already located found another location in Hoboken to put a camera that's pretty flood prone, but that's a location that floods about 100 times per year presently. And then on the right is Camden, New Jersey, a location in collaboration with Drexel, Franco Montalto, where they have ultrasonic sensors looking at flood depth on the street. This can be very complementary. There's widespread network. There's a network in New York City called FloodNet, which is deploying hundreds of sensors around New York City. Those ultrasonic sensors just measure flooding at one point using a time of flight for the echo to return. But these cameras can be very complementary, and that's one thing we're studying is the complementarity of these different sensor networks, because these cameras can make a spatial measurement, essentially, of flooding. Here we are in OceansMap. I think we'll talk more about this, but there's the 3 locations with deployment so far in OceansMap: Rockaway, Hoboken, and Camden. These are deployed with solar power, mobile cellular communication. The little rail link cameras are shown here. And so here's you could actually see the view perspective in OceansMap of the camera view. And I'll mention that it's part of a broader network also. We're collaborating with Greg Dusek and Jeremy Cothran, who are behind WebCOOS and from the Sakura IUS team, and they definitely helped us along, and we also show our cameras in the WebCOOS network. They've been very helpful. So what are some applications of street flood camera observations? First, just telling the story of what's happening and understanding the problems that lead to flooding. This is a case where we get snapshots every 10 minutes through the system. I can turn on video, but we just automatically collect 10-minute snapshots. This is a snapshot where I've subsampled it every half hour. So it's about 2 hours of sampling. The top left one, there's a stormwater sewer, and the water's just starting to emanate from it. It's got kind of a white coloring, reflected color to it. Then it spreads out a little bit by half an hour later. And then it's getting out onto the street and up onto the sidewalk an hour later, eventually crossing the street. There's multiple stormwater sewers and the flooding from them is all merging together. There's a car driving through the water. So it tells the story very clearly that there was stormwater sewer backflow, which is something that the property owner had, where we have the camera mounted, a nonprofit has been complaining about, and the city hasn't solved over multiple years. But this is a particular day. This is a flood frequency of a high tide level that happens about 7 times per year, so not extremely unusual that this occurs at that location. So we can tell the story, provide evidence of the flooding. We're also working on image segmentation. Actually, we really didn't make as much progress as I'd like. It was sort of an add-on to the project with a grad student or a master's student working on it, and she's gone now. But we made a little bit of progress and learned the limitations of her, the techniques she was developing for image segmentation to identify the flood and eventually turn it into a flood area estimate and a flood map. But there's a lot of groups working on this, so this is definitely an area that will be seeing great improvement, and that'll be a tool that's used with these cameras to make the data more quantitative. And lastly, I have a PhD student who has a chapter who's about to defend, actually, Shima Kasei, who, with Kei-John Liu, another professor with expertise in machine learning here at Stevens, developed a long-term, short-term memory model that outperforms bathtub modeling. So Russell on the left, Beach 84th on the center column, and Hoyt on the right column, transition from dominantly tidal flooding to compound flooding to rainfall-driven flooding. And the bathtub model gets worse and worse as you go toward more of a role for rainfall flooding, and it doesn't even perform that well to begin with when your tide gauge is pretty far away that you're bathtubing from. It gives you a fairly bad prediction of the flood depths. And so the flood depths from the machine learning model, LSTM model, are much better across many metrics. So that research is submitted to American Meteorological Society special journal issue, and also the AGU 2025 meeting in New Orleans. And so what this could lead to, this is just a demonstration using hindcast data, which is more accurate than forecast data, but this was a 30-minute prediction into the future, and the performance was better at 10 minutes, and it was slightly declined at 30 minutes, but it was still fairly good. And so we imagine that this could be developed into a forecast system where people's phone buzzes them and it says, you know, in 20 minutes or half an hour, you're going to have a foot of water. And based on radar and model-based nowcasting of rainfall, and I didn't mention this is based on rain data. The machine learning model is based on rain data and offshore water levels from our forecast system, actually, but as I said, in hindcast mode. So it enables us to extend our water level forecast system to be a flood forecast system that includes pluvial forcing in an urban environment. And we envision that could give people warnings of on the order of an hour in advance of flooding. All right, and the last thing I'll talk about is our new project, which is looking at New Jersey's northern coastal bays and looking at water level, flood forecasting, and wave observation and forecasting. So a special motivation here is these back bays, these back barrier estuaries, sometimes called lagoons, are areas that are very much understudied. Tide gauges historically have been located in harbors and ports and deeper water areas, and these systems have only been observed for about the past 20 to 25 years maximum by United States Geological Survey. I saw Chris Schubert was on the line. Thanks for your help with those measurements, Chris. And so there are areas that are understudied and under-forecasted, but tide and wind-driven flooding are a more frequent problem than most of the harbors and ports, in part because a lot of property is low-lying, built on top of wetland landfill in the middle of the 20th century, and on top of tidal marshes. There's land subsidence. The tides are often fairly small in these back barrier estuaries, and so the storm surges are smaller, so the homes are not very high above typical high tide. So a foot of sea level rise over the past century is leading to chronic flooding in some of these areas. And so there's not much forecasting. Even Stevens flood forecast system, as I already acknowledged, has its some of its worst performance in the back barrier estuaries, and that's why we're looking to develop a new model for improved forecasting. Here's a few pictures of northern Barnegat Bay flooding and mantaloking. The project goals are to provide critical information on water levels, waves, and flooding in these northern back barrier communities of the Jersey Shore from Atlantic City northward, apply an innovative combination of modeling, wave and water level observations, and street flood sensors and community engagement to develop tools that improve preparedness for flooding among these communities. The task areas include engaging communities to learn of their forecast needs, providing useful information to them. We've already learned from the New Jersey Sea Grant Consortium meeting last January that blowouts are another thing of interest to boaters. The water levels can get too low for passing certain areas when the winds are blowing water out of the bay. So it's not only about flooding and waves. Learning their specific needs. We will be intercomparing different wind wave measurement technologies. I'll show that on the next slide. Developing plans for operational coastal hazard products, seeking community input, setting up operational long-term observations using a SOFAR buoy, and finally determining the best water model for the above needs that we're learning about in year one. And over the next year, we'll be developing the models and evaluating them and validating them and tuning them against observations. And finally, operationalizing this improved modeling for the northern back barrier systems of New Jersey. And so far, the progress on this has been, we purchased an ADCP on departmental funding, actually. We purchased the SOFAR buoy on the MARACOOS funding. We're going to intercompare these measurements to learn sort of the limits of the SOFAR buoy in an environment that they haven't been used as much in, with very small waves and relatively shallow water, often less than 2 meters deep. We've begun conversations with NOAA, with Saeed Mogimi, to tap into their expertise and sort of the next generation modeling and forecasting system tools that they're using. Hoping to use Sphinx as the schism model for capturing water hydrodynamics from deep ocean all the way up to rivers and creeks with one single mesh. We're also exploring using the Sphinx reduced physics model. It's a more simplistic, rapid model that may be valid to use in this system. We'll evaluate its accuracy, but we've been setting that up because if it's faster, it may be easier to run a whole ensemble of different weather forecasts that enables us to better quantify uncertainty. And when you have the more complex models, it can be difficult to have the computational power to run these large ensemble predictions. And lastly, we've had initial engagement discussions with Bayhead, where we're planning on deploying a camera, Long Beach Township, and Atlantic City, where we also hope to deploy a camera. And those are some of our primary stakeholders so far. We've been learning and hearing a lot about how rainfall flooding is really important part of the problem. So that may influence to focus on capturing both the tidally driven and storm surge driven flooding and the rainfall flooding. So to conclude, street flood observations, including cameras, can contribute to societal flood mitigation and preparedness. They can complement or even be used to create forecasting systems. And lastly, coastal community flood resilience can be improved through combined engagement, flood and wave monitoring, and forecast systems. So I'm happy to answer any questions. I don't know if we're going to go to questions now, or I think we are, or take it later. Thank you.
All right, folks, and we will go ahead and allow for some time for questions for both Tina and Philip. Tina, one question I have for you is you talked about building two-way conversations. Can you give an example on how community input has already shaped decisions in this first year?
Yeah, so in Maryland, for example, Tim and his team are driving around, going to all these different locations, like to towns, counties, and having conversations with the communities and local partners to get an idea of where that first batch of sensors in the Eastern Shore should have gone. And another one is even in Virginia, just having the community feedback that plays a huge role in shaping where those sensors will be deployed. So, I mean, even though we're still in the early stages of this project, that kind of direct input is already making a difference. And it's exactly the kind of ongoing conversation we want to keep having, not just this first year, but throughout this project to see if it's not happening now, like later, where these sensors would be best for the communities.
Wonderful. Thank you. And then Philip, we've got a question for you in the chat. How far away are you from providing reliable forecasts of neighborhoods? And what is your vision for the right number of sensors?
Great question, Dave. Neighborhood inundation has been possible. It's been done. It's just a question of having the right models for Barnegat Bay and these other bays. We'll have it within a few years under this project. We're certainly moving toward that, and it depends on how detailed of modeling we want to use. NOAA is moving toward using bathtub modeling of sorts for coastal flood inundation mapping, flood forecast mapping. We can do that. We can also set up more complex models. So that's a key question, and this project is sort of one of our pilots for going in that direction of providing mapping instead of just water level predictions. What's the vision for the right number of sensors? That's a tough question. I mean, it's not for every single neighborhood, obviously. I think the models can take over at some point. If we're using that machine learning modeling technique, then it's developed around a sensor. And so a data-driven model requires a sensor. If we're using these water models, then they can be improved using the observations, but then they also have the detailed physics in them, in many cases, to create maps of flooding instead of water level prediction. I see a lot of questions popping up. So I see, is Ocean from Ellen Prager. Hi, Ellen, nice to see you. Is OceansMap going to be the dissemination tool for forecast and flooding info? That's a great question. We haven't talked about it yet. One thing we know we'll do is we'll wrap our forecast for Barnegat. We think we'll wrap it into our existing flood advisory system, and we'll have at the locations of tide gauges, we'll have those water level predictions as a time-dependent predictions into the future. But then it depends on, we could also have flood mapping in that system, and it's something we need to move our website toward, is flood forecast mapping. So I think it'll be there, and I think there's a good chance it'll also be part of OceansMap, but we haven't discussed that yet. And I'll keep going.
Yeah, you got another question from Dave in there as well.
Dave says, question 2. Phil, have you worked with NOAA's Coastal Modeling Division at VIMS to see their accuracy and plans for improved inundation modeling? So NOAA's Coastal Modeling Division at VIMS, I didn't know there was a, and I think you might mean the people at VIMS who are creating models that are used and operationalized by NOAA, Joseph Zhang and others, I think probably, but I'm not sure. To see their accuracy and plans for improving inundation, definitely interacting with them, yeah. And I was on a seminar yesterday where Joseph Zhang was actually presenting, and it's a NOAA seminar series. So trying to interact more with them because they're really pushing the envelope at NOAA. They're doing great work. And also people at VIMS like Joseph. So aware of them, definitely. Ellen Prager asks, as an academic institution, how do you plan to transition from research to operations, which requires full-time monitoring, maintenance, to be sure it's operational full-time? Well, Stevens has had operational forecasting and observations for 25 years now, or so, at least 20 years. As I mentioned, the water level forecasting has existed for 20 years. And so it's something that we've been doing, but it is always a challenge. It's one of the things that MARACOOS has really come around at just the right time for me. I've been engaging with MARACOOS, and the funding for MARACOOS is for this, right? It's for operational tools that are useful to society. But outside of MARACOOS, it can be difficult to get that kind of funding. NOAA tends to only fund studies that will operationalize usually within NOAA's own systems, which we haven't done previously. So it's hard to get, it's nice to have a organization through IOS and MARACOOS that funds academics to also be developing these tools and educating the next generation of professionals. So that's our perspective on that. But it is a challenge. Alan Blumberg, who's one of the creators of SFAS and the NIHOP system, asks, he says, I like that you emphasize forecasting where people are. How do you plan to inform the public for these new forecasts? Great question. Anybody else want to pitch in? Certainly through social media, and that's one thing that MARACOOS specializes in. And we're engaging, like I said, with Atlantic City, Long Beach Island. There's already groups like Long Beach Island already has their emergency management tapped into our forecasts, and it helps them with their emergency management, the water level forecasts, however imperfect they currently are. So some of it's just remaining engaged with those communities, but between Atlantic City, Bayhead, Long Beach Township already, we're engaging with a lot. Often we engage with the experts in the emergency management, but we also hope that the website, to improve our web resources so that they're more, they have a simple upper layer where the average person could interact and get information. And maybe we'll develop apps, and be putting the same things on apps just to get the data out even more widely. And another question from Dave Jones. He says, Phil, me again, smiley face. Have you thought about providing output from your forecast system as a web service so that other GIS systems can ingest and share the output? That's a great question. I've heard that NOAA's moving in that direction, and I think it's something we really need to think about. So, very good point. Dave, feel free to reach out if you're with an organization that would let us use this kind of data. I think the data is meant to be public if it's funded through MARACOOS and NOAA, and there's no reason we couldn't do that. It might require more work or more effort, but it is definitely something we should work toward. And that's all the
Awesome.
questions I see so far.
That is all the questions I see. Does anyone else have any other questions at this time?